In the previous video, we lightly touched on some of the functions like linear functions or quadratic functions. Now, let's start from the fundamental principles of it. A function is generally denoted by y equal to fx. Say for example, we have a function here y equal to fx. Sometimes you will see the function with the notation like y equal to gx or y equal to hx. But actually they are all the same, but just make use of different symbols to denote the functions. The key is what kind of algebraic expression that fx or gx or hx are referring to. Say for example, fx is referring to a x to the power 2 plus bx plus c. And then gx is referring to ax plus c, which is the linear function. Here is the quadratic function. That is the algebraic expression really matters. But no matter what kind of notation it uses, x here is referring to what we call the independent variable. And y here is referring to what we call the dependent variable. So y is called, this one y is called dependent variable is because it is actually dependent on the value of x as the input to the function here. Y is the resultant value. X is the values that you pick as an input for this function. That's why x here is called independent variable. It's independent of any value of y or the other values. For y is actually dependent on the values of x. And also bear in mind that under the function here, multiple values for x here can be mapped into the same value for y variable here. However, a single value of variable x here cannot be mapped into multiple values of variable y. So what does that mean is that, let's say we have an example here with y equal to fx. Let's simply define this function as x to the power 2. So simply on the left-hand side we have the value for x, and then on the right-hand side we have the value for y, it's the output variable. So let's randomly set x to be equal to 0 or 1 or 2, and then the corresponding outputs for y is 0, 1, and 4. Very easy. So you can see that's the mapping here from x to y here is 1 to 1 and then 2 to 4 here. So very simple. This is the function under the x to the power 2. At the same time, if you take on x to be value equal to -1, the mapping will be like this from -1 to the value of y, because -1 under this function is equal to 1, the output. So obviously, as we mentioned previously, multiple value for x, this one, multiple 1 and -1, it actually can be mapped to the same value for y on the right hand side. However, not the other way around. So for a single value for x cannot go in two different directions, like it cannot go 0 and 1 or 4. Only from here to only one output on the right hand side, which is the y variable. So this is the key features of the functions. In other words, every value of x here has only one corresponding output value of y, or it is equivalent to saying that for a function, you can tell what y is, right? Once you know what x is. Let me explain further. If you look at the xy coordinate here, y and x here. If you look at a very simple example, which is the linear function here, the graph actually described by y equal to ax plus c. Say for example, if you pick any real values for x on the x-axis here, say for example here, immediately you see that there's only one and only one corresponding outputs for the value of y here, right? Here. So it cannot happen that you pick single values for x here that give rise to two different values for y. It's not possible. Similarly, if you look at the quadratic function here, say it is y equal to ax plus bx plus c. So you can have two different real values for x right here that give rise to single values for y. Say for example, y is equal to b, right? You have two different real values, a1 or a2. That's under this function here, quadratic function, that's resulting the single values for y, but it cannot be the other way around. Say for example, you have one single x value here, but give rise to two different y values. That's not possible. So in terms of the coordinate plane here and also the mapping here, you see that the principle of function is that the output variable for y can only be single values. So that is the key part of the functions. But now there's an interesting question. In the xy coordinate plane, we can have the formula like this, describing the trajectory of the circle. So we have y here, x here. We have the formula here, which is x to the power 2 plus y to the power 2 equal to 1. Actually, this is 1 for the x-intercept. So in this formula here, you will immediately calculate the subject of y, which is do some simple operation on this formula here, equal to 1, and then you put the x, go back to the right hand side of the equation, and then you take the square root of the whole expression 1 minus x to the power 2, just like this, and then plus and minus. So this one's the question is this the function? It is somehow a little bit similar to here. We have the y variable and then x as the inputs here, but in fact this expression or this algebraic expression is not called function. It is not function because obviously when you put a single values, or say for example you put certain values into the x variable as the input, and then for the output that actually result in two different values. One is the plus, the other is the minus. So that's one single x values that give rise to two different y variable values. This is not called functions. So if you look at the xy plane coordinate here, if you say for example pick certain particular values for x here, that's actually result in either these values for y and also these values for y. Here, obviously it is not a function. Rather than saying function for the xy here, we say there is relation on x and also on y. Relation on the real numbers is a set of ordered pairs of real number. Say here, the ordered pair here xy actually follow the relationship under this equation. So you can imagine that function is literally a subset of relation. Here is the function and it is the relation here. The graph of function is a relation. However, a relation does not necessarily mean a function. Formally speaking, a function is a relation such that for each x here, there is at most one ordered pair xy. But don't worry too much about relation because relation is usually not the topic covered in the high school math curriculum. You just need to be aware of the difference here between function and relation and focus mainly on the topic function as we are discussing here. When it comes to function, there are some terminologies you also need to know about, which is domain, codomain, and range. So domain is actually represents the set of all the values of x under consideration. And then the values of x is usually referring to the real value. Say for example, when you go back to our simple example here, we look at the column here, the value here is actually corresponding to the what we call the domain, but actually it is one of the few real values we pick for illustration. Actually, it can be extended to different real value like -2, -10, or -1.1, say for example. This is the domain, or say this is a set of values as an input to the function. And the second term is the codomain. Codomain actually is on the right-hand side of the graph here. Codomain represents the set of all the values, also usually referring to the real values of y under consideration of the function y equal to fx. So the codomain actually is pretty broad. It can refer to -1, -10, or 1000, they say for example. So for the codomain here, it's actually including all the real values, including the negative number, as shown here under this set of number. The last term is the range. Range actually represents the set of all possible values of y under the function. Obviously, if you look at the function here, it is x to the power 2. All the non-negative number will be under the output of this function. So if you look at the example here, -1, -10 is not the range. It's not the values under the range. It is minus, all the minus here, the negative number is the values under the codomain, under consideration. But for the range, it actually refers simply all the positive or non-negative values as the output, which is called the range. And please note that codomain may not be equal to range, as we explained earlier. Now, here are some examples of functions. So you're quite familiar now with the linear functions here, and also the quadratic functions here. And also on the part here, it actually show the graphical representation of the functions. So in the graphical representation, we usually study the features of the graphs like the domain, the collection of the value for x, as reflected on the x-axis here, and also the range here, which is referring to the set of values under the functions here. And we will also study the x-intercept and also the y-intercept of the functions. Particular for quadratic function, we will also study the vertex of the parabola. We say that we study the maximum values of the quadratic function or minimum values of the quadratic functions. And then we will learn more about in the later videos about different forms of the straight line here that can be expressed in terms of the algebraic expression. And also for quadratic function, we learn about some special form of the quadratic function, so that you will be able to find out the vertex of the or the maximum minimum of the quadratic function more easily by the method of completing of square. And lastly, we see the graphical representation of the polynomial here. And in later videos, in this particular chapter on polynomial, we talk about factorization, these interesting topics under the polynomial. So these are all the features that we will study in great detail later in the later video. And then one important point I want to call out here is that when the question asks you about the x-intercept or y-intercept, it's not talk about the coordinates. The answer should be the real number, because when you look at, very simple, the coordinate points here very easily is the 0 and then b. But in fact, the question asking about the y-intercept of the equation here or of the function here, the answer should be just b, but not this point on the coordinate. Just bear in mind this difference. So in short, learning the graph is very important, because graphical representation can usually assist us in better understanding the functions and also solve the equation. Remember what is equation, right? Equation is actually related to function. Obviously, say for example, for function here, y equal to 6x plus 5. If you change the variable here, y, to set the value, say for example, equal to 0, then now it will become the equation. And then once you see the equation, then the aim is to find out the roots of the equation or find the value so that the left-hand side is equal to the right-hand side. So the value here is actually this one. Now, let's take a look at the following work examples about functions. For this question, actually, it is given a function called fx equal to ax to the power 2 minus 2ax plus 1. This is the functions, quadratic functions, and also give you the additional information about a particular input value for x, which is 4 now, and then the corresponding output for y, which is 41 here. And then where a is just a constant, x is the variable, a is a constant. So the first part of the question is asking us to find the value for a. So when we look at the question here very easily, then we first of all, we need to make use of the information here and try to substitute this information like the value for x, which is 4, into this function, and then substitute the value of y, which is 41, into this function. So immediately we can do the math here. f4 equal to a 4 to the power 2 minus 2a, and then 4 plus 1. Just the whole expression here on the left-hand side, which is 41, and then do the calculation here is 16a minus 8a plus 1, and then immediately you calculate here, which is 8a, and then here is 40. So immediately you calculate, the value for a is actually equal to 5. So for the part A, it's pretty easy to calculate. But now it comes to part B. Now it is actually give you the expression here like this. f2x equal to 10x to the power 2 minus 12x plus 3. So there's actually we can split this question into two parts. First of all, we want to understand what does that mean for the first part, which is f2x. This is actually related to the later part 3 we will explain in the videos later about the transformation of function. For the expression like this, you multiply the variable x here by a constant here, either greater than 1 or less than 1. Actually, that will have an impact on the resulting function. We call the transformation of function. Actually, we transform the function fx here from fx to some other function, which is f2x. This one actually we can denote this one by a new function called gx is equal to f2x. Then immediately, very simply, you just do the simple math here. Like previously we calculated the value of a, which is 5, so we can put 5 here and then 2x here to the power 2, and minus 2, 5 here. Obviously here is the which is the 2x, and then plus 1. So very quickly we can do the math here. It is 20x to the power 2 minus 20 again plus 1. So this is the new functions for gx. So this is the first part about solving this problem. So now the question is asking about, now given you have the function here and also you have the function here, this is the other function, like maybe we say hx. So the question is asking about to equate this function with the function here. So what does that mean is that, like in a graphical representation of the quadratic function, we have here y is x-axis and the x-axis here. We have two quadratic function. One is the gx, the other is the hx. Say for example like this, hx. So if you set the two functions to be equal, that means you have the chance to solve the equation, solve the quadratic equation, because when talking about equating of the two functions together, the aim actually is to find out the intersection of the two functions. Or to be more specific, we want to find out the intersecting points of the two functions. There can be no intersecting point. Say for example, it can be one of the functions like this, the other function is like this. There can be no intersecting points, or there can be one intersecting point, or there can be two intersecting points. So that's why here, for this part, after we transform function to gx, and then the question is asking about equating these two functions together, which actually referring to equal to hx, which is the plus 3. So immediately you can do the calculation here, do the common calculation on the same terms, like 20 minus 10 x to the power 2, which is 10x. Very easy. And then minus 20 x here, and then here is minus 12x. The result is minus xx. And then here obviously for the constant term, which is minus 2. This is the final equation that you need to solve to find out the intersecting points of the two quadratic functions. So to further simplify the expression here, so we will do the x to the power 2, and then minus 4x, and then minus 1. So this is obviously very simple, common standard form for the quadratic equation. And then immediately you do the simple factorization here, which is equal to 5x plus 1, and also the x minus 1. So immediately you can find out the root, which is equal to x equal to minus 1 over 5, and also or x equal to 1. And this is the solution for part B. So one more points to mention here is that for the question like this, to solve the quadratic equation or find the roots of the quadratic equation, we usually make use of the scientific calculator to do so. Many scientific calculators have the programming functionality that allows you to input the program directly on the calculator so that you can obtain the results more quickly, rather than going through the tedious calculation by way of the traditional formula. Of course, even though the calculator program can help, you still need to understand how to use the formula to calculate the roots. In my later videos on quadratic function, I will demonstrate how to input the program into the scientific calculator in order to find the roots of the equation. But for illustration purpose here, I can quickly do the math here directly on the calculator. Say for example, we choose a program here. We know there's a free constant, 5, minus 4, and minus 1. So immediately we can input the parameter 5 here, the first term. And then we further input the minus 4 on the second parameter, and then we execute. And then further we input the final constant, which is the minus 1 in the calculator, and then execute. So immediately the calculator will give the result, which is the first result, which is the b squared minus 4ac, which is the discriminant of the quadratic equation, which is equal to 36. So if you press the execute again, it will calculate the first root of the quadratic equation, which is equal to 1. If you press the execute again, you will calculate the second root of the quadratic equation, which is the minus 1 over 5. So obviously with the use of the scientific calculator, it's very easy. You can calculate the roots of the quadratic equation very efficiently. So we will talk about how to do so in the later videos. But one more important point to mention is about some of the misconception about the function. apart from the fundamental principle of the functions as we just discussed, there are some misconceptions that you need to be aware of. First of all, it is about this first point, which is kfx is not equal to fkx. So for functions, actually, there's no such thing called kfx is equal to fkx. In other words, the arithmetic operations on variable here do not apply to the whole function here, generally. And similarly, if you look at the second formula here, fa plus and minus fb is not equal to fa plus or minus b here. Similarly, for the multiplication here, doesn't really apply the function at all. Please bear in mind these important misconceptions. On the next part is about the composite function. So it is called composite function because it is a function within a function. Similarly, gfx is not equal to fgx. So bear in mind this important point. Lastly is about this part. Fx is not saying f multiplied by x. Similarly, in terms of the division here, for this trigonometric representation here, cosine 3 theta and cosine theta cannot be equal to the expression like 3 theta over theta here. Simply delete the cosine here is not correct. So this is about the key misconceptions related to the function. And this is the end of part 1 of chapter 1. In the next video, on part 2, we will continue the topic of function and we'll give you an overview of different types of functions that usually appear in your math curriculum. Lastly, if you like the video, please subscribe my channel and like my video. See you later.